ठीक है, A cross B basic formula is AB sin theta n cap. AB sin theta is representing the magnitude of the resultant vector. N cap is giving the direction of the resultant vector. Okay. Now n cap, what is n cap? It is a unit vector perpendicular to A vector and B vector both. Okay, A vector and B vector both at the same time. So this is your n cap vector. Acha. How to find the direction of n cap? Okay, we have already discussed those two methods. Okay, first is Fleming's left hand rule, or second is right hand thumb rule. Okay, so these are the two methods to find the direction of n cap vector. Acha. So these were the things which we had discussed earlier. Acha. Now let's come. Mute your mics. Mute your mics. Whoever mic is there, just mute it. ठीक है. So these were the things we had discussed in the last class. अच्छा. Now suppose, ठीक है, now if vectors are given to you, ठीक है, if a particular vector is drawn or some way the vector has been represented in the direction like northeast, northwest and all that, ठीक है, then you can use these two methods. But what will happen if your vector is represented as a cap, a1 I cap like this? Okay, we have done this in the dot product also. A2 j cap plus a3 k cap. Okay, how to calculate the cross product if I have been given my vector in the form of standard unit vectors, that is I cap, j cap and k cap. Okay, so let's assume, okay, let's assume that a vector is this, b vector will be b1 I cap plus b2 j cap plus b3 k cap. Okay, what we need is we need to find a cross b. Okay, what is the value of a cross b vector? We need to find this. Okay, so there is a particular method, there is a particular way to find this a cross b. We will see that, but first the basics. Okay, what are the basics? You can just note it down. Okay, first of all, what will be the value of I cap cross I cap? Anybody?
1.
The one.
1.
One.
Don't
One,
guess.
sir.
Try to calculate first. Calculate first. Okay, just try to solve it. Okay, you have the basics. Okay, you have this formula. Try to use this formula for I cap and I cap.
So 0.
0. That's it. Okay, not 1. It is 0. Okay, why 0? Okay, just try to understand. I have a vector as I cap, b vector as I cap. Okay, that means a vector is also like this, b vector is also like this. So you can see that both are parallel vectors. Okay, both are parallel and equal vectors in fact. So magnitude is a different matter. The angle between these two vectors, is 0 degree. Okay, so if it is 0 degree, you will replace a cross b as ab sine theta. Sorry, ab sine theta and cap. So instead of theta, you will replace over here 0. Okay, sine 0 is 0. Okay, so if sine 0 is 0, this complete magnitude becomes 0. So whatever be the direction, I don't have to worry about it. It is a null vector. Null vector can have any direction because the magnitude is 0. Okay, so I cap cross I cap will always be equal to 0. Okay, similarly, j cap cross j cap will also be equal to 0 because again the angle between these two vectors is how much? It is 0 degree. So the cross product will be 0. Then again k cap cross k cap will also be equal to 0. Okay, so this thing you have to remember, and now that cross product of same unit vectors is 0. Okay, in dot product it was not the case. Okay, in dot product it came out to be 1. Okay, but in cross product it is 0. है ना? अच्छा, let's see another note. Can anybody guess? Not opposite, ठीक है? Not opposite to dot product, ठीक है? It is just the way the dot and cross product have been defined. ठीक है? In dot product we use cos theta. Now cos 0 is 1. Now we cannot help in that because cos theta is 1 only. ठीक है? You cannot define cos theta, cos 0 as 0. ठीक है? Cos 0 is 1, so we have to use it as 1. Here sin 0 is coming, so sin 0 is 0. We cannot help that. That is the basic definition. Okay. So it is not opposite. It is just the definition in which they have just been defined like this only. Okay. They have a definition like this. So you just have to remember it. Okay. Just a basic thing that you have to remember it. Okay. I will write another point which will help you to differentiate between dot and cross product. Okay. But after that, not now. Acha. Where was I? So I cap cross J cap. Anybody? What could be the answer for I cap cross J cap?
1.
K
1.
cap.
See. K cap. Somebody said K cap. Yeah, that is correct. Okay.
Yes,
I
sir.
have told you that cross product gives me a vector quantity. So the answer should be a vector. You are saying 1, that is also correct. That is not wrong. But you are only giving me half an answer. You have only given me the magnitude. Who will give me the direction? N cap will give me the direction. Okay? And in I cap cross J cap, the N cap comes out to be K cap. Okay? So basically what we do is we just write it like this. I cap cross J cap is equals to K cap. Okay? Nothing much we have done. Okay? Just the starting basics we have done over here. Okay?
So I cap into K cap will be J cap.
I cap cross J cap will be K cap. Yes. Okay? Don't say into. Now you are going into vectors. Start using dot and cross. Okay? A dot B. A cross B. Okay? Don't say into. Into is multiplication. Okay? That is mathematics.
Okay.
You're in physics.
So sir, now if we switch any one of the vectors like I cap cross K cap, then that will be equal to J cap.
I will discuss this. Don't worry. I am just coming to that only now.
Okay, sir.
Okay. Now
Okay,
see,
sir.
there is a method to remember this. I cap cross J cap is K cap. Similarly, when we write J cap cross K cap, it comes out to be I cap. And similarly, when I write K cap cross I cap, it comes out to be J cap. Now there is a method to remember this. There is a method to find the answer for two unit vectors, standard unit vectors. Okay, that is, we draw a circle like this. In anti-clockwise direction, I J K like this. Okay. Now see, suppose someone is writing J cap cross K cap. Okay, just for example, we are saying someone wants the answer for J cap cross K cap. Okay. So see, J cap is this. Okay, K cap is this. J cap is your first vector. K cap is your second vector. Okay. So you move from first vector to second vector. First vector to second vector. You are in the direction of the circle. Okay, the motion of the circle is anti-clockwise. You are moving in anti-clockwise direction from first to second. So the answer will be plus, and the third remaining vector will be my final result. Okay, plus I cap. Na? Suppose, let's see another example. Okay, let's see another example. Suppose someone writes हाँ. Basically, you are using Fleming's left hand rule only, but you are representing it in terms of I cap, J cap, and K cap. Okay. So this is a bit better to understand for those who are unable to use Fleming's left hand rule. Okay.
So
This
this
is
is
a
the new method now.
this is that method which I was talking. Okay. It is basically the fundamentals only. Okay. It is basically the rules only. Just a better way to remember. Okay. It is just a better way to remember the directions. Okay. Acha. So now let's go for another example. Okay. This is done. Now suppose somebody has written that it is K cap cross J, not K cap. Let's go for J cap cross I cap. Okay. So let's suppose somebody has written the formula. What is the value of J cap cross I cap? So the final result will be the third vector. Okay. J cap is there, I cap is there. The third vector left is K cap. So K cap will be the answer, but plus or minus you have to decide. Okay. So how to decide plus and minus? Just see the direction of motion. Okay. You are going from,
Minus.
yes, that's minus. Okay. You are going from J to I. Okay. J cap to I cap. Okay. So J cap to I cap is in the clockwise direction. That is, you are going against the circle. So a minus sign. That's it. Good. Okay. So you are getting the idea. So now let's suppose, okay, once you get this circle, okay, once you get this I cap, J cap, K cap method, just imagine now someone asks you what is the direction of A cross B if A vector is like this and B vector is like this. Suppose what will be the answer you can say? Okay, again I will draw the options. 3, 4, 5, and 6. Okay, again we have 6 options and you have been given A and B like this. Okay, what should be the answer for A cross B? What should be the option out of these 6? Okay, try to use this I cap, J cap, and K cap.
So third one.
Correct. Use correctly. Try to visualize it. See what I am.
So fifth.
Nahin. It is the 6th one. Just see how. Okay, just see how I am getting that. Okay. No, it is the 6th one. 6th one is the answer. Just wait. Okay, just wait. Yes. Okay. You know this is X. You know this is Y. You know this is Z. Okay, X, Y, Z. Z is coming out of the plane. Okay, it is not in the plane of the paper. It is coming out. That means you can draw like this. That dot is K cap and cross is minus K cap. Like this you can draw. Okay. Now see, A vector is in the I cap direction. It is in the plus I cap direction. Okay, so you will replace, instead of A vector, replace it as plus I cap. Okay, cross B vector is in which direction? It is in the negative Y direction. That means minus J cap vector. Okay, I have already told you that the negative axis direction is always represented by minus. Okay, so negative Y is minus J cap, negative X is minus I cap, negative Z is minus K cap. So this is minus J cap. Now do what? You can take the minus sign out, take the plus sign out. So you will have plus into minus, minus I cap cross. You will have minus of I cap cross J cap. Okay. I cap cross J cap can be calculated from this circle. Okay. From this circle, calculate I cap. Okay. It will be directly K cap. Okay. You can see that. And because I cap is this, J cap is this, K cap is the remaining vector. That should be the answer. Sign, we are moving from I to J. That is, we are moving in anti-clockwise direction. So plus. So I cap cross J cap will come out to be plus K cap. Okay. but the minus sign is already outside, so final answer will be minus k cap. Okay, and also minus k cap is which direction it is?
Again.
Yes, again. Okay, just see, you have to understand that dot product and cross product are only applicable for vectors. Okay, positive sign, negative sign. Mute your mics. Okay, positive sign, negative sign, scalars all are multiplied by scalar multiplication as normal. Okay, the way you multiply 5 into 4, that is 20, that is normal multiplication. Okay, minus 5 into 4 is minus 20, that is normal multiplication. Okay, so scalars are multiplied normally, but dot and cross are used only for vectors. Okay, their magnitudes have no dot product or cross product, they have just simple multiplication. Okay, so what I did here, see again, I'm rubbing this. Okay, just see again. Okay, first of all, write the directions of a vector and b vector. Okay, a vector is like this, so a vector is in the x, positive x direction, so plus I cap. Okay, b vector, you can see that it is in the negative y direction, so minus j cap. Okay, now see this plus sign and minus sign. Okay, they can be written like this: plus 1 I cap in cross minus 1 j cap, right? Like this can be written. Okay, so plus 1 and minus 1 are what? They are basically scalars. So scalars will be multiplied like scalars only. Okay, so if scalars are multiplied like scalars only, what you can see here is that it is plus 1 into minus 1 into I cap cross j cap. Okay, I removed them out of cross product. Okay, acha. Now plus 1 into minus 1 is minus 1 only. Okay, and I cap cross j cap. Okay, I cap cross j cap, from this circle we can understand that it is k cap. So I will write this as k cap. Okay, so finally what the answer I am getting is minus k cap, and minus k cap means cross direction. Okay, so this is a bit
Okay, sir, understood.
remember. Yes. Okay, so this is just a bit easier method to remember.
So what's
Okay,
the last sign?
Sir, but how you
cross
got cross?
I told you na that.
So it's in the negative direction, so it should go downwards, right?
Yeah, downwards means what? It is cross na. I told you this in the last class, that a vector.
I didn't attend the last class. Okay.
Acha. Okay, so it was discussed in the last class, hai na? That any vector coming out of the plane will be denoted by dot. Any vector going into the plane will be denoted by cross.
Okay, sir. Okay, got it.
Yes. Okay. So we can see here that minus k cap is going into the plane, so that is why cross I have written this direction. Okay, sixth one will be the answer. Okay. Hope everybody got it.
Sir,
Yes.
sir, why is cross or dot?
Y is up or down? Na? This 3 and 4 would be, this is plus y, this is minus y, this is plus x, this is minus x, this is plus k, this is z. Okay, this is plus z, this is minus z. You can remember it like this.
Okay, sir.
Okay. Achha. So again, let's see another example so that I can check whether you know or not. What should be the direction of A cross B out of these 6 options only again? Okay, the same 6 options are there. You have to find A cross B for the new example, this one. Third one, check correctly. Check your answer. Check your answers.
So fourth?
ठीक है, fourth. Anybody else? Fifth is also there. Check your answer. Yeah, check your answer. I need a unanimous answer. Okay, I need a single answer, unique answer. At least shorten your range. Okay, now I am having 3 options. At least come down to 2. You can write it in chats, है ना? Fourth, ठीक है. Fourth, question mark क्या होता है? You are asking or telling me? You have to answer ना. Good. Nice. ठीक है. So don't be in a hurry to answer the questions. ठीक है. Take your time. There is no hurry now. ठीक है. You will have to hurry in later classes. ठीक है. Later chapters, not now. ठीक है. You are learning now, so take your time. Fourth is the correct answer. ठीक है. Fourth is the correct answer. Very good. ठीक है. How fourth we came? ठीक है. Again, let's see the calculations. A vector, ठीक है. If I am talking about the directions of A vector, I can see that it is in the negative x direction. ठीक है. Negative x means minus I cap. ठीक है. Cross B vector is in the downward direction, inward direction, that means minus k cap. ठीक है. So what I get is, ठीक है, take the minus sign outside from both the I cap and k cap. You will have minus into minus outside. ठीक है. There will be a minus into minus 1. ठीक है. Not 1, let's write it as minus into minus into I cap cross k cap. ठीक है. I cap cross k cap. Minus into minus will become plus. ठीक है. And I cap cross k cap, again go to this circle. I cap cross k cap, that means the answer should be j cap. What will be the sign? It will be minus sign. Why? Because we are going from I to k. ठीक है. If we are going from I to k, the answer will be minus because we are going against the circle. So minus j cap is the answer for I cap cross k cap. So I will replace this as minus j cap. ठीक है. So final answer which I am getting is minus j cap. Minus j cap direction means like this. ठीक है. I have already written over here plus I plus x minus x plus y minus y plus z minus z. So basically you can say that fourth one is our answer. ठीक है. So this is how you can solve the directions. ठीक है. Another just a bit you can say a bit easy method to remember. ठीक है. Instead of right hand thumb rule and Fleming's left hand rule, ठीक है, it is a bit more mental than physical. ठीक है. Right hand rules and left hand rules are physical work. ठीक है. You have to physically use your hand. ठीक है. This is a bit of mental maths, you can say. So it is a bit easier to remember. I have seen that you are easily understand these methods. Okay, so that is why we discussed this. Okay, so whichever is suitable to you, I have given you 3 methods to find the direction of cross product. Okay, one is Fleming's left hand rule, one is right hand thumb rule. Both are physical methods. You have to use your right hand and left hand in that. Third one is this cross product. Okay, this circle method, you can say. ठीक है. I cap, J cap, K cap method, whichever is suitable to you. ठीक है. It is not a standard method. ठीक है. You won't find this in books or all. ठीक है. It is just a method we regularly use in practice. ठीक है. So whichever is best for you, whichever is useful to you, you can use that. अच्छा. So this was just the basics of cross product. ठीक है. What we wanted was to find the cross product of A vector with B vector. ठीक है. We wanted this A cross B. ठीक है, not single I cap and J cap and K cap. ठीक है, we wanted the complete set. अच्छा, now see, the basics is same, still the basics is same. What we will do is we will replace this and this over here and write it. ठीक है, A cross B can be written as A1 I cap plus A2 J cap plus A3 K cap cross B1 I cap plus B2 J cap plus B3 K cap. ठीक है, again the distributive form of multiplication, distributive law of multiplication will be applicable over here, like we did in dot product. You remember this, that all the terms are multiplied with each other. So A1 I cap will be cross multiplied with this, this, and this. Similarly, A2 I cap will be multiplied by this, this, this. Similarly, A3 K cap will be multiplied with all the three terms. Okay, so I will again show you only the first one. Okay, only the first one, because the method is very lengthy. Okay, this is the time taking method, so I will show you another method to calculate it. Achha. So what I get is when I multiply A1, okay, when I multiply A1 with B1, B2 and B3, okay, so I get A1 I cap cross B1 I cap. Okay, this is the first term plus A1 I cap plus B2 J cap, second term, sorry, not plus, sorry, into cross plus A1 I cap cross B3 K cap. This is the third term. Okay. Now see, the scalar A1 and B1 are scalars. Okay, they will multiply separately. So just take them out, A1, B1. Okay, what I am left is with I cap cross I cap. Okay, I cap cross I cap will become 0. We have just seen this. Okay, now plus A1 into B2. Okay, these two are scalars, A1, B2 are scalars, they will come out. You will have I cap cross J cap. Okay, I cap cross J cap, we have just seen that this becomes K cap. Okay, I cap cross J cap becomes K cap. So this is the second term plus third term. Again, A1 and B3 are scalars, they will multiply separately, and I cap cross K cap will be there. This term becomes minus J cap. Okay, I cap cross K cap is minus J cap. You can see from the circle, okay, that I cap, J cap, K cap circle. You can find what will be the value of I cap cross K cap. Okay, so in the first term, you can see that we are getting this. Okay, now again we will do this for A2 also. We will do this for A3 also. Okay, so there will be a complete big answer behind it. Okay, you can understand when I multiplied the first term, I am getting two terms for it. Okay, I am getting two terms for it. Similarly, when I multiply A2, okay, A2 J cap with all the three terms, again I will get the first and the last term. Okay, when I multiply A3, I will get the first and the second term like this. Okay, this will become 0, this will become 0. Okay, so that is there are, you can imagine, 6 terms being formed over here. Okay, there are 6 terms. Now, how to combine, how to find a shortcut method to calculate these 6 terms? Okay, the method to find this is determinant method. Okay, we call it as determinant method. Determinant method. Okay, what is determinant? Determinant is a mathematical tool, okay, used by computers to store stuffs. Okay, the computer, when you, if you study languages, okay, computer languages, or you must have studied, they store data in the form of matrices. Okay, so matrix is a way to store data. Okay, to get an output from the matrix, you need determinant. So determinant is a mathematical function. Okay, you don't need to get into the depth of determinant and all that. Okay, you just need to understand how to calculate the value of a determinant. Okay, so how to use this determinant method is important for us. Now see, I have a vector a1 I cap, a2 j cap plus a3 k cap. Okay, all the 6 terms we are going to calculate, but with a different method. Okay, this is a very lengthy process. Okay, if you go by the this method, okay, it will take you around half the time of the paper. Okay, so don't go by this method. Okay, better use determinant method. So what is that? We will discuss that. b1 I cap plus b2 j cap plus b3 k cap. Okay, now you want to find a cap, a vector cross b vector. Okay, so first of all, draw two parallel lines like this. Okay, with some gap between them. Acha. Now this determinant has 9 spaces. Okay, it has 9 places. That is, it is a 3 by 3. It is a 3 by 3 storage space. Okay, it is a 3 by 3 storage space. Okay, so you have to fill in these spaces by some value. Okay, by some value. What are those values? You need to understand that carefully. Okay, this is the first row, this is the second row, this is the third row. Okay, now see, in the first row, always write the 3 unit vectors I cap, j cap, and k cap. Okay, in the first vector, no matter what is the value of a vector and b vector, always the first row has I cap, j cap, and k cap as the 3 terms, as the 3 spaces. Okay, next, let's come on to the second row. Okay, in the second row, your first vector should be placed. First vector. Okay, which is our first vector? Our first vector is a vector. So a vector's coefficients will be placed in the second row. Okay, what are the coefficients? Like see, the coefficient of I cap in a vector is a1. So I will replace the first space with a1. ठीक है, पाइथन, हाँ ठीक है भाई यार, ठीक है, पता है तुम्हें आता है. ठीक है, अच्छा. So second row, okay, the first space will be filled by the I cap coefficient of a vector, that is a1. Okay, second space will be for a2, that is the j cap coefficient of a vector. Okay, similarly third will be for a3. Okay, you can guess that it is the k cap coefficient of a vector. Okay, in the third and the last row, what we replace is the second vector's coefficients. Okay, we replace the coefficients of the second vector in the same manner as we did for the first vector. Below I cap, I will replace b1. Below j cap, I will replace b2. Below k cap, I will replace b3. Okay, so this is the determinant of A cross B. Okay, whatever is the final result we get will be representing a vector which is A cross B. Okay, now we will learn how to open this. Okay, we have to open this, we have to calculate, do some calculations on this also. Okay, but before that, let's see what is the change we get when we try to write A cross B. Sorry, B cross A. Okay, A cross B we have already written, but now we have to write it as B cross A. Okay, so if we want to write B cross A in the form of determinant, okay, again we write parallel lines. Okay, first row I cap, j cap, and k cap. Okay, then in the second row, the first vector, in this case my first vector is B vector. If it is B vector, then the coefficients of B vector will be there in the first row, sorry, second row. Okay, so what are those coefficients? B1, B2, and B3. Okay, and A vector is your second vector, so its coefficients will be there in the last row, third row. Okay, so last row will be A1, A2, and A3. Okay, so this is how you write this is how you represent the determinant of A cross B or B cross A, whatever, whichever you need. ठीक है, first vector in the second row, second vector in the third row. That's it. ठीक है. Now we need to open this determinant. Now we have to calculate the value of this determinant. ठीक है, how to calculate it? ठीक है, let's see. A cross B we had I cap, J cap, K cap, A1, A2, A3, B1, B2, B3. ठीक है, we have to open this. ठीक है. Now first of all what you do is you write the signs plus, minus and plus over the I cap, J cap and K cap vectors. ठीक है, you simultaneously you yourself write it. ठीक है, it is not given in the determinant. You are writing it. You are introducing these signs over here. ठीक है, why? I will tell you. Now see, I have to open this determinant. So what I do is I take the first term, that is I cap. Okay, I take the first term as I cap. Now I cap, I am opening the term I cap. Okay, I am writing the first term I cap over here. How to open this, how to solve this I cap term? See, first of all, it has plus sign over it. So I will write a plus I cap with it. Okay, into what you do is you eliminate this column, you eliminate this row. Okay, you eliminate the row and column containing I cap vector. Now you are left with A2, A3, B2, B3. To open this, what we do is we use cross multiplication method. Okay, to calculate the value, we use cross multiplication method. What does it mean? That you are going to write A2 B3 minus B2 A3. This will be the first term of your resultant vector. ठीक है, whenever you cross multiply, there is a minus sign in between. How many pages? बताओ भाई जनता. How many pages should I leave? How can I know how many pages you have to leave? Leave around 4 or 5 pages.
So 3 to 4, sir. That's enough.
Okay, 3 to 4. ठीक है, Leonard. 3 to 4. Yeah, 3 to 4. ठीक है, अच्छा. So this was our first term. हाँ. So this was our first term of I cap. ठीक है. Now forget all this. ठीक है, forget all this, whatever we have done in red. Now let's. अरे यार, sorry. ठीक है, जनता listening seriously. ठीक है भाई. ठीक है. Now let's come on to the second term. ठीक है, the second term is J cap. ठीक है, second term is J cap vector. So what I will do is I will write J cap over here. ठीक है, I will write J cap over here. Now since J cap has a minus sign over it, I will provide it with a minus sign like this. I will write it as minus J cap. ठीक है. Now the term which is required to be the coefficient of J cap, you can say. ठीक है, the coefficient of J cap, how to calculate that? Again, eliminate the row and the column containing J cap. ठीक है, eliminate the row and column containing J cap. ठीक है. Now you are left with A1, A3, B1, B3. So what you do is again we cross multiply the terms. ठीक है, that is A1 B3 with B1 A3. Again a minus sign in between those two. ठीक है, that means I will write it as A1 B3 minus B1 A3. ठीक है, this is how we write cross multiplication for coefficient of J cap. ठीक है, in fact for any coefficient, ठीक है, if you are opening determinant, we have to use this method only. ठीक है. अच्छा, now let's go to the third term. Okay, let's write in green. Okay, so this forget again j cap. Okay, you have done I cap, you have done j cap. The last term left is k cap. So again, remove all this. Okay, forget all this. Okay, let's come to k cap. So write the term k cap over here. Okay, now k cap has a plus sign over it. So write plus k cap. Again, we have to write coefficient. How to write the coefficient? Again, remove the column and the row containing k cap vector. Again, you are left with four terms, a1, a2, b1, b2. Again, use cross multiplication. So just cross multiply it like this, like this. So the term which you will get as the coefficient will be, finally I will add them. Okay, just wait a minute. Okay, a1, b2 minus b1, a2. Okay, a1, b2 minus b1, a2 is the term which I will get. Okay, so now I have got three terms. What you have to do is, that's it. Okay, you have got I cap, you have got j cap, you have got k cap. The final answer will be like this: I cap a2 b3 minus b2 a3 minus j cap, okay, because minus sign is there, a1 b3 minus b1 a3 plus k cap because plus sign is there, a1 b2 minus b1 a2. This is the final result which I will have. You can check here, you have 1 2 3 4 5 6 terms in this. Okay, and by the basics we were also getting 6 terms. Okay, so this is how you open determinants. This is how you calculate determinants for finding cross products. Did everybody got that? Okay. If you have any doubts, you can ask. We will do a few examples also now. Don't worry about that. Obviously, you have been given a vector and b vector in unit vectors. So your answer should be in I cap, j cap, and k cap only, na? Okay. Acha, if you change the sign of unit vectors, then your answer will change. Okay, your directions will change. Your answer will be something different. Okay, direction is a very important part of vectors. You are changing minus j cap to plus j cap. That means you are just reversing the direction of the vector. Okay, you are just making it from now towards north. Now it is going towards south. It is like that. Okay, so it makes a big difference. You cannot do this. Okay, you have to remember the sign associated with it. You cannot just change the direction. Okay. Okay. Why it is just a mathematical tool, just they have defined it like this. Okay, plus minus plus. I also don't know the reason behind it, but in mathematics they do this. Okay, if you would have taken mathematics in 12th standard, you have this chapter as matrices and determinants. So there they explain in detail, okay, what is the use and how to open and that all. Okay, but I don't think many of you have taken mathematics. Okay, but still those who have taken will have a brief idea of what they will be doing in that. Okay. And it is not necessary also. Okay, just it is a method, it is a process to find, it is a process to store information and get answer from it. Okay, it is a shorter method. See, writing this 6 terms is a very lengthy process. Instead we write it in the determinant form, so that is a bit easier to represent. That's it. Okay, so this was the method. You have to remember this in mind. Okay, I will do one example. Okay, another example you will have to solve. Okay, I will use a very easy example. I will give you a difficult example. Don't worry about that. Okay, that is how the world works. So I cap, j cap, k cap. I will use it. I will explain this method using numbers now. Okay, now not variables. It is better to understand when I am using values. 2i cap 3j cap plus k cap. Okay. So now I have a vector like this and b vector like this. Okay. Now what I am asked is, what is the a cross b vector? Okay. What is the vector a cross b? So what I do is I write a cross b like this. Okay. I draw the determinant. Okay. Take your time. Don't worry. Okay. Once you get the habit of opening determinants, na, it will be less time taking. ठीक है, now it will be looking like sir इतना time कहाँ से आएगा. ठीक है, don't worry about that, don't worry about that. Once you get the practice, once you are in flow, ठीक है, you will solve it within minutes. ठीक है, it takes less than 1 minute to solve a determinant. ठीक है, you just need to know the method, you just need to know the process, you just need practice, you can say. ठीक है, so a cross b, draw the determinants, write I cap, j cap, k cap over here. Then the first vector, what is the first vector? A vector. Coefficients of a vector, what are those? 1, 1 and 1. So 1, 1, 1. Okay. Then we go to b vector, second vector. The second vector's coefficients are what? 2, 3, 1. Okay. 2i cap, 3j cap, k cap. So 2, 3 and 1. Okay. Now let's open it. Okay. Plus, minus, plus. Remember, plus I cap, coefficient of this, remove this. Okay, I am left with 1 and this 3 and 1. So I will write it as 1 into 1, 1 minus 3 into 1, 3 minus 3. Okay, now remove this. Let's go back to j vector. Okay, j vector is with a minus sign, so minus j cap. Okay, into remove this row, remove this column. Okay, row and column, sorry. So again cross multiply this. 1 into 1 is 1 minus 2 into 1 is 2. Okay, again I have the coefficient and the j cap term. Remove all this, forget all this. Now write k cap. Okay, it is plus k cap, plus sign is there, so plus k cap into, remove this row, remove this column. You have 1 into 3, 2 into 1. So 1 into 3 is 3 minus 2 into 1 is 2. So final vector which I am having is I cap into minus 2 minus j cap into minus 1 plus k cap into 1. So finally I have minus 2 I cap plus j cap plus k cap. This is the final result. Yes. Okay. So this is how you can write, you can find the a cross b vector. Yes, that's it, correct. Okay, so this is how we solve the cross products. Now I will give you another question. Okay, you solve it, take your time. Okay, initially you will take around 2 to 3 minutes to solve it. Okay, so take your time, don't worry about don't rush. Okay, if somebody is giving the answer, don't worry about them. Okay, don't worry about time. This is your practice, you can say. Okay, so let's see. Okay, get me the answer for B cross A. Okay, take your time. No need to worry about time. क्या कर रहे हो तुम लोग यार? It is a vector quantity. I need it in I cap, J cap, and K cap. What is 8? What is minus 5?
So no, it's looking like S.
Acha. Sorry for that. I was thinking you were talking about answer. It is minus 5, minus 2, and plus 10. Sorry. ठीक है ठीक है ठीक है. Check the signs. Check the signs and value is also not correct. ठीक है, I am getting a different value for one of them. क्यों? You should you should know how to calculate it without seeing your method यार. ठीक है, no problem. Check the signs. Vivek, check your signs. Your magnitudes are correct, but your sign is wrong. Still not correct. Yes. This is the correct answer. Rucha is correct. Plus 18 plus 35 plus 16 should be the answer. Check your signs. Check your signs. Okay, I hope everybody is getting this answer only. Okay, I am also getting plus 18 I cap plus 35 J cap and plus 16 K cap. This should be the final answer. Yes. Okay, so initially it will take time. Don't worry about it. Okay, you need time. You are in the learning stages, so don't worry about what will be the answer. Yes, I will just solve it. Okay, don't worry. Okay, so take your time. Don't worry about me or others. Okay, take your time. Solve it at your own pace. Okay, later on you can increase your speed. Now let's see how to solve this. Okay, they wanted B cross A. Okay, they wanted B cross A. So first of all, I will write I cap, J cap, K cap. Okay, I will write I cap, J cap, and K cap in the first row. Then first vector is B vector. Okay, so I will write the coefficients of B vector below it. That is -5, -2, and 10. Okay, -5, -2, and 10. ठीक है ना? So there itself you are wrong. Okay, so you have to be attentive and you have to check what they are asking, what you are calculating. ठीक है. Next is A vector. Okay, next is the second vector, A vector. A vector is 3, -2, and 1. 3, -2, and 1. So let's write the first term plus I cap. Okay, plus I cap. Yes. Okay, so if I'm writing plus I cap, remove this row, remove this column. Okay, I will have -2 into 1, that is -2, minus of -2 into 20 is -20, so -20, like this. Okay, then forget this. Okay, acha, plus minus plus I forgot to write. Okay, plus I have written plus over there. Acha. Next is minus J cap. Okay, minus J cap because minus sign is there over it. Okay, again remove these two. Okay, if you remove these two, I will have -5 into 1, -5, minus of 3 into 10, 30. Okay, next remove, next the term is K cap plus K cap. Okay, because plus sign is there, so remove K cap and row and column of the K cap. You will have -5 into -2 is plus 10, minus of 3 into -2 is 6. ठीक है, now just solve it. So plus I cap, ठीक है, if you don't write plus doesn't matter, plus I cap minus 2 plus 20 minus J cap minus 5 minus 30 is minus 35 plus K cap plus K cap is 10 minus of minus 6 is 10 plus 6, that is 16. So what we have is 18 I cap plus 35 J cap plus 16 K cap. Yes, ठीक है, so this will be the final result. ठीक है, so you need practice on this, ठीक है, because cross product will be used again in rotational motion and all that. ठीक है, rotational motion you have a complete chapter in which there is only cross product. ठीक है, basically you can frame a question based only on the cross product in rotational motion. ठीक है, so that is a very important part.
Sir, can you just zoom out?
Yeah. Okay.
Yes, sir, enough.
Okay. So you need to do this practice on this questions. ठीक है. अच्छा. So this is how we can calculate cross product and dot products. ठीक है. Hope everybody got this. Any doubts in this? That I will explain. I will explain now. Don't worry about that. Okay, I will tell you this. Okay, some points are remaining. Some basic definitions are left. Okay, between dot and cross.
Sir, done.
So after the class, you will take FBD now.
Yes, from 2 to 2:15 to 20, you can say FBD will be done. Don't worry about that.
Okay. Thank you so much, sir.
Okay. ठीक है. So this was the basics of cross product. ठीक है. This is how we calculate cross product. This is how we determine cross products. अच्छा. Now a few important points regarding the products. ठीक है. Dot product or cross product. ठीक है. You can just write it as a note like this. ठीक है. So first point is that A dot B is equal to B dot A. ठीक है, go back to dot product. You will remember that I had told you that A dot B and B dot A are representing projections of A on B. ठीक है, geometrical meaning if you remember. ठीक है, so I write A dot B or B dot A, both are having the same value, that is equal to AB sin theta. ठीक है, A dot B and sorry cos theta, not sin. AB cos theta. And A dot B or B dot A both are having the same scalar value, AB cos theta. Yes. Okay, it is cos theta. Sorry for that. And second point, in dot product only, you can say that if two vectors A and B are perpendicular to each other, then A dot B is definitely equal to 0. Very important result. Okay, you must have seen that whenever I wrote I dot J, I wrote that as 0. Whenever I wrote I dot K, I wrote that as 0. Whenever we wrote J dot K, we wrote that as 0. Why? Because they are perpendicular vectors. Okay, they are perpendicular to each other. So you can extend that result to general vectors also, not unit vectors only, to general vectors also, that whenever two vectors are perpendicular to each other, their dot products will be 0. Okay, so that is one of the features which can be used somewhere, okay, to determine something. Okay, so this is one of the notes. Acha. Next, let's come back to cross product. Okay, so when I write A cross B, okay, suppose you are writing I cross J. Okay, I cross j comes out to be k cap. ठीक है, just let me write a small example over here. I cap cross j cap, you write this as k cap. ठीक है, but just tell me, what do you write j cap cross I cap? What will be the value of j cap cross I cap?
Minus K cap.
Minus k
Minus
cap.
K cap.
Yes. Minus k cap. ठीक है, good. ठीक है, so basically what we are seeing here is that j cap cross I cap can be written as minus of I cap cross j cap. ठीक है, I cap cross j cap is k cap, so this will become k cap only. ठीक है, so the next note is this only, that if A cross B is written somewhere, then you can write it as negative of B cross A, or vice versa, that if B cross A is asked somewhere, you can just reverse the direction of A cross B. Magnitude will remain the same. ठीक है, the magnitude of A cross B will be equal to the magnitude of B cross A, but the directions will be opposite. Okay, the magnitudes won't change, but the directions will be opposite in nature. Okay, so this is a result which you can remember, which you have to remember, in fact. Okay, hope it is clear. Any doubts in this, anybody? Okay.
No, sir.
Yes, nice. Chalo, next. Fourth. ठीक है, fourth
Let's do
point
it,
is
sir.
that क्या let's do it, competition चल रहा है यहाँ पे. ठीक है, चलो. Fourth point. ठीक है, fourth point is that if two vectors A and B are parallel or anti-parallel, to each other, then A cross B will be equal to 0. ठीक है, this is the main use of dot and cross product, to identify whether the vectors are perpendicular or are parallel or anti-parallel. ठीक है, whenever someone says to check whether these two vectors are perpendicular to each other, I will do what? I will find A dot B. If A dot B becomes equal to 0, then I will say that A and B are perpendicular to each other. If not, they are not perpendicular to each other. If someone says that someone tells me to check whether A and B are parallel to each other or anti-parallel to each other, whatever, I will do what? I will calculate A cross B. If A cross B comes out to be 0, I will say yes, they might be parallel or anti-parallel, but they cannot be perpendicular to each other. Okay? And if it is not equal to 0, then we cannot say that they are parallel. They may be something else, they may be at some angle, but they are not parallel at all. Okay? So this is the main, you can say, the main use of dot product and cross products. Okay, is it clear? Any doubt in this? Okay, you have to remember this thing. Okay, the fourth point and the second point are the most important points of multiplication. Okay, if a question will be asked, it will be asked on this only. Okay, is it clear? Anybody having any doubts? Okay.
Can you just zoom out
Yeah.
so that I can see all the 4 points like that?
Yes, no problem. Yeah. Okay. So this was everything about vectors. Okay, our vectors is finished today. Okay, we have done addition, we have done the basics, we have done addition, we have done subtraction, and this concludes multiplication. ठीक है, there is no such thing as divisions of vectors. ठीक है, don't worry about that. If division comes, then it is a wrong statement. ठीक है, you cannot divide a vector by b vector. That is not possible. ठीक है, a vector divided by b vector is not a term. Why no division? यार, I cannot exactly say about that. ठीक है, the mathematics were not defined by me. ठीक है, somebody else defined them. He did not define division for that. So do you want divisions? Eh? You want something extra in vectors more? Eh? This was not enough for you. ठीक है, so don't worry about it.
Enough.
This is
So more than enough.
Yes, this is more than enough. So don't worry about it. Okay, if you go into research and development, then you can discover your own division of vectors. Okay, but for now, till here only. Okay. Okay, so you want examples also. Achha. So I have to create an example for that. It is possible. Okay, you can discover anything you want. Okay. Okay, suppose this is the question. Okay, you have been asked whether you have to check whether a vector and b vector are parallel or perpendicular to each other. Okay, so what you will do is, since they are asking about perpendicular also, okay, so you have to calculate a dot b also and a cross b also. Okay, because if it is perpendicular, a dot b will be 0. If it is parallel, then a cross b will be equal to 0. So you have to check both. Okay, so first check a dot b. If you check a dot b, you will find that it is coming to be 0. Okay, just check it. Yes. Okay, so since a dot b is coming 0, I will not calculate a cross b. Okay, I will directly say that since a dot b, okay, since a dot b is coming out to be 0, therefore a vector and b vector are perpendicular to each other. Okay. Now suppose in some case, okay, in a different case, that a dot b was not equal to 0. Let's see another example for that. Okay, I will have to create another example for that. Okay, suppose these are the two vectors. Okay, so you have to check whether it is perpendicular or parallel. Okay, you have to check this. So what you will do, first of all, you will find a dot b. So as and when you find a dot b, you will see that a dot b is coming out to be 1. So it is not equal to 0. So therefore, a is not perpendicular to b vector. Okay, we can safely say that. Okay, now what I will do, I will go to a cross b. Okay, if I go to a cross b, I will have to use the determinant method because it is in I cap, j cap, and k cap form. So a is 1, 1, 1. B is 1 minus 1, 1. So if you solve this, you will have 1 plus 1. Okay, so this is also not coming out to be 0. So just wait then, just a minute. Okay, suppose this is the vector. Okay, instead of 1 1 1 it is 2 2. Okay, so that P will come out to be 4 5 6. Okay, it will be 6, which is not equal to 0. And so again it is not equal to 0, so still it is not perpendicular to each other. Okay, but if I calculate A cross B, you can see that it is 2. This will come out to be I cap 2 minus 2 plus J cap 2 minus 2. Sorry, plus minus J cap 2 minus 2 plus K cap 2 minus 2. So this comes out to be 0. Okay, so here you can see that A cap cross A vector cross B vector is coming out to be 0. So therefore I can say A vector is parallel to B vector. Okay, so they can ask you such questions in the form of options. Okay, they will give you a vector that which of the following vectors is parallel to a vector. Okay, they will say you this, which of the following vectors is parallel to a vector. They will give you 4 options. Out of the 4 options, one will be this B vector. So you will have to check. Okay, for each of the 4 vectors, you will have to check A cross B, A cross B, A cross B, A cross B 4 times. Okay, whichever is giving you 0 will be the answer. Okay, so that is how they try to frame such questions. Okay, hope it is clear. Yeah, ठीक है, so that is questions part. ठीक है, you can understand the questions if you know the basics. ठीक है, so this is the end of your vectors. ठीक है, all the topics, all the points which are important for vectors are done. ठीक है, so now let's start with differentiation.
Sir, please scroll up.
Yeah. क्या लिखा है सर? So this is one for dot product. क्या है वो? What is that sign? हाँ, ठीक है आ रहा है. Why are you getting so excited? ठीक है, so this was your dot and cross products. ठीक है, next we will do differentiation. हाँ, cos theta is equal to 1 for dot product. Yes. ठीक है, in the second question है ना, in the second question if you try to find the magnitude, ठीक है, so it will be a b cos theta. So there cos theta you will replace cos theta as 0. ठीक है, so that will become 1. ठीक है, we can only define that once we have a cross b equal to 0, once we have determined that both are parallel. Okay, how you got 6? Yeah, that is dot product. ठीक है, you have to calculate dot product for that. है ना? So I have already told you that whenever we find dot product between one A and B vector, you do what? You just multiply the coefficients of the respective terms and add them. So 1 into 2 is 2, then plus 1 into 2 is 2, again plus 1 into 2 is 2, again plus. Okay, so 2 plus 2 plus 2 is the answer. So that is 6. And I try to remember these basics. Okay, every time there won't be someone to, you know, tell you this again and again. So just try to remember these things. These are the basics. Okay, whatever you have studied in this chapter, okay, it will be used till the last chapter of physics in 12th. Okay, so this is such a basic, this is such a fundamental thing. Okay, that till the last chapter, till the 12th last chapter, that is semiconductors, you will be using vectors everywhere. Okay, everywhere. Dot product, cross product, addition, subtraction. It will be like a common day, common phenomena for you. Okay, it will be like rain and all. Okay, yeah, it is raining on so common. Okay, so you have to get used to it. So how to get used to it? Just practice. Practice as much as you can, as much as you can. Okay, you must have got your modules. You must have given your tests. Okay, you have many questions with you. Okay, acha, if you want books, okay, reference books, the best book for practice is H.C. Verma. Okay, there is no replacement for that. Don't go for theory in H.C. Verma. Okay, the questions of H.C. Verma are so, I mean, so well defined, you can say, for practice. Okay, that once you understand some topic, na, next question will be based on that topic. Okay, third question will be based on the previous two topics. Okay, so it is a very structured, question pattern it has. Okay, so that is a good book for practice. Another book you can refer is DC Pandey. Okay, I have not used DC Pandey, but I have seen that it is good. Okay, I have not used it. Okay, I have not solved questions of DC Pandey. Okay, but I have heard that DC Pandey is a good book for practice. Okay, there are many questions. Okay, there are lots and lots of questions in that. Okay, previous year NEET questions, previous year AIMS questions, previous year AIPMT questions, everything is there. ठीक है, जो लोग इरोडो बोल रहे हैं ना, वो पहला क्वेश्चन देख के दे विल जंप आउट ऑफ देयर बिल्डिंग्स. ठीक है, सो डोंट गो फॉर इरोडो. ठीक है, इरोडो इज नॉट मेंट फॉर नीट. ठीक है, इट इज मेंट फॉर जेई एडवांस. ठीक है, इवन द बीटेक स्टूडेंट्स, द कॉलेज स्टूडेंट्स आर अनेबल टू सॉल्व सच क्वेश्चंस. ठीक है, दैट इज सच डिफिकल्ट लेवल ऑफ क्वेश्चंस आर देयर. सो डोंट गो फॉर इरोडो. ठीक है, आई एम वार्निंग यू बिफोरहैंड. ठीक है, इफ यू लूज योर कॉन्फिडेंस, डोंट टेल मी कि सर आपने बोला था इरोडो. ठीक है, SL Arora, yaar, I have again not seen that. ठीक है, when I was doing my 11th 12th, I used HC Verma only, and that was more than enough. ठीक है, if you do HC Verma, it is more than enough. ठीक है, so I have to see SL Arora, but SL Arora also I have heard that it is good for theory and all. ठीक है, it is good for theory. Practice also, obvious questions will be there, so you can do practice from SL Arora also. No problem in that. ठीक है, ठीक है. हाँ, after 12th you can definitely solve Virodo. ठीक है, after 12th you can solve Virodo whenever you want. ठीक है, no one is going to stop you. है ना? ठीक है, अब फालतू बातें बंद, बहुत हो गया, है ना? Sir, which book you spoke about? Which one means there are two books which I said. ठीक है, one is HC Verma. ठीक है, one is HC Verma. ठीक है, the book's name is, I guess, Fundamental Concepts of Physics, something like that. I don't remember the title of the book, but HC Verma has only one book for physics. ठीक है, by the writer's name. ठीक है, HCV, it goes HCV. So you can find that. ठीक है, again for DC Pandey is the second book. ठीक है, DC Pandey, these are the two books. ठीक है, the books are normally found by their writer's name only, so you don't have to worry about the topic, the title of the book. Okay, so these two books are good. Okay, H.C. Verma and D.C. Pandey. S.L. Arora, I have to check. Okay, I cannot comment on S.L. Arora now. Okay, but I have heard that it is good. I have to see that book, but it is good. I have heard it is good. Okay. These are just for practice, and don't try to study theory from it. Okay. Sometimes the statements are very poorly written. Okay, theoretical part is very bad for it. For boards, H.C. Verma is too much. Okay, H.C. Verma, if someone is solving H.C. Verma, NEET will be like cake for you. Okay, and JEE mains can also be easily solved if you do H.C. Verma sincerely. Okay, remember this. H.C. Verma is such a good book that you can do even JEE mains questions. Okay, physics questions from that. Okay, if you have sincerely done H.C. Verma. Okay, so don't worry about boards. Boards is fairly easy. Okay, once you get the basic idea, okay, you understand the basics of physics. Okay, boards will be like walk in the park for you. Okay. Okay. So, and our most preferred book is H.C. Verma. Nowadays, D.C. Pandey is also catching up. So D.C. Pandey is also good. Whichever book you prefer out of these two. Okay. Now 20 minutes are there. Let's see what we can do. Okay, we can at least do the basics of differentiation. Okay, so let's start with differentiation. Okay. Now don't try. Okay, if you have maths, okay, then also don't try to go in depth in differentiation now. Okay, we just need differentiation for calculation purposes. Okay, to make our physics easier. So don't try. Okay, don't try to see that what actually Newton said, what actually somebody said about differentiation. Okay, you just need to understand what is differentiation. Okay, what does differentiation's geometrical meaning is, and the formulas which define differentiation. Okay, so these are the three things which you need to do. What is differentiation? Basic. Okay, geometrical meaning of differentiation and the rules and formulas of differentiation. That's it. Okay, you don't need to go in the depth. You don't have to worry that अरे sir ये तो mathematics है, calculus क्या 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 होगा. Okay, because calculus is overrated. Okay, you don't have to worry about that. Okay, the mathematicians have tried to overrate it. Okay, it is an overrated thing. You don't have to worry about it. We have just to learn the basics of the differentiation. Achha. So what is differentiation? Okay, differentiation is a process of finding the slope of a line. Okay, it is you can say it is a method to calculate the slope of a line or tangent to a curve. Okay, this is the main use of differentiation in physics. That's it. ठीक है, मैथमेटिक्स वाले बोलते रहेंगे कि differentiation is something else, but we don't need that. ठीक है, we only need to find the slope of the tangent to a given curve. ठीक है, why we need that? Because you must have studied in motion in straight line that there is something called as instantaneous velocity. Okay, you must have studied in instantaneous acceleration. So to calculate those things, okay, that instantaneous terms, that instantaneous values, you need differentiation. Okay, so differentiation is basically just a method to calculate slope of tangent to a curve. Okay, for us that is more than we need. Acha. Now, how did?
Excuse me, sir.
Yes.
What have you just said? Please repeat.
about what that
Just now,
instantaneous.
why it is used?
Why it-
Instantaneous. That.
ठीक है. Just I will explain that again. ठीक है, just see here. Suppose someone asks you to write the average velocity. Average velocity. ठीक है. So the formula for average velocity is, you know, it is delta x by delta t. Okay, it is delta x by delta t. Delta x means x final minus x initial. Final position minus initial position is the distance or the displacement of the particle divided by the final time minus the initial time. Okay, this is what is in average velocity meaning. Okay, this is what average velocity represents. Okay, now if we have a graph, suppose we have a graph of x versus t. Suppose, okay, let the graph of x versus t be like this. Okay, the graph is something like this. Okay, let it be like this. Doesn't matter. Okay, suppose the graph of xt is like this. Now someone asks you that what is the average velocity of the particle from t1 seconds to t2 seconds. Okay, so this is x1. Okay, correspondingly at t2 time it is at x2. Try to understand the meaning of x1 and x2. Okay, that means a particle is moving on the x-axis. Okay, a particle is moving on the x-axis at t equal to t1 seconds. Okay, at t equal to t1 seconds, the particle is at x equal to x1. Okay, and at t equal to t2 seconds, the particle is at x equal to x2 meters. So if you want to find the average velocity, okay, average velocity is distance or displacement upon time taken. Okay, this is the basic formula of velocity. Velocity is equal to distance upon time. This is the formula. So the distance covered is how much? It is this much. Okay, suppose somewhere here there is origin. Okay, x equal to 0 is somewhere here. So if you see by the terms of vectors, okay, try to understand this by vectors. The particle was initially having a vector of x1. This was vector x1. Finally, the particle was having vector x2. So what is the distance covered by the particle? Okay, so I can say the distance covered by the particle is x2 minus x1 magnitude. Okay, sorry, this is the displacement, not the distance. This is the displacement. Okay, this is the displacement. Now, if someone asks you what is the distance, okay, what is the distance? If someone asks you what is the distance, distance will be basically x2 minus x1, the magnitude of these two vectors. That's it. Okay, difference of the magnitude of these two vectors, that is x2 minus x1. Okay. Acha. Now, what is the time taken? Okay, time taken. Let's talk about time taken. Time taken will be what? At t equal to 0, it was at x equal to 0. Let's assume. Okay, let's assume that at t equal to 0, it was at x equal to 0. So now at t1 seconds, I started measuring the time. Okay, suppose t1 second is 5 seconds. Just for example, I am saying. Okay, and at t2 second, t2 is 10 seconds. So what is the time taken to travel this distance? It is 5 seconds. How did you come to that? You came by subtracting final time minus initial time. Okay, you came by 5 seconds as t2 minus t1. That's it. Okay, so this is the time taken. And now if someone asks you what is the speed, average speed, you will write distance upon time. You will write it as distance upon time, average speed someone asks you. So this will be x2 minus x1 upon t2 minus t1. So this is how we write average speed, average velocity. Acha. Now if someone wants to find this value, okay, someone wants to find this value in the graph, okay, everything you have represented on the graph, but velocity is not represented on the graph anywhere. Okay, so how to do that? Okay, what I do is I start at point A, which is at x1. Okay, I finish at point B, which is at x2 on the graph. Okay, what I do is I join A with B. I join A with B. Okay, now see, now I will draw a right angle triangle over here. Okay, this is the right angle triangle. Okay, ABC. Let's this point be C. Okay, now imagine this angle as theta. Okay, what is this theta? Theta is representing the angle of line with plus x axis. Okay, theta is the angle of the line with the plus x axis. है ना? अच्छा. Now if someone asks you what is the value of tan theta, okay, in terms of A, B and C, what will you write? You will write BC upon AC. Okay, this will be tan theta. Now in terms of mathematics, tan theta represents the slope of line AB. Okay, tan theta is representing the slope of line AB. Okay, tan theta is represented as, tan theta means in mathematics slope of line AB. It is represented by m. Okay, small m most of the time. Okay, now let's just see what is the you can say the length of BC in terms of x1, x2 or t1, t2. Okay, you want this length. So if you see here, this length is x1, this length is x2. So BC is how much? You can see that BC is x2 minus x1. BC is x2 minus x1. Okay. Similarly, if I'm asking you what is the value of AC in terms of time, okay, you will say that this is AC, sir. Okay, what is that in terms of time? This till here is T1, this here till here is T2. So AC you can see is T2 minus T1. So yes, that's it. Okay, so what I am concluding over here is that the slope is represented as x2 minus x1 upon t2 minus t1 for line AB. Okay, slope of line AB is x2 minus x1 upon t2 minus t1. So what I conclude from here is that I am writing here. Okay, I will let you write that whole thing. Okay, don't worry. I conclude from here that the slope of line.
Sir, can you scroll up?
Just a minute. Let me write this. The slope of line AB is representing the average speed or velocity of particle from A to B. Okay, this is the meaning of your slope. Okay, first of all you need to understand what is slope. So this thing is represented as slope. Okay, the slope of line AB in the graph f xt. Okay, if you're drawing a line AB on x-axis and x and t graph means position time graph. X is position, t is time. So if you are drawing a line in xt graph, in position time graph, the slope of that line gives you the average velocity.
Done,
Okay.
sir.
ठीक है, most of you must have to write, ठीक है ना? So this is what is the geometrical meaning. This is how you represent velocity on a graph. ठीक है, you draw xt graph, you draw a position time graph, and draw a straight line between the points A and B. That straight line's slope will be the average velocity. ठीक है, अच्छा, now just see again. ठीक है, this was average, everything was average, so no problem. अच्छा, now if I'm talking about average over here, you can see that this AB line, ठीक है, this AB line is basically a chord. ठीक है, what is chord? Chord is a line that cuts the curve at two distinct points. ठीक है, that is a chord. So if this line AB is making a chord, then I will say that it is representing average velocity or average speed, whatever. ठीक है, now just imagine, ठीक है, let's move on to instantaneous. ठीक है, till now we were on average speed. ठीक है, I guess no problem in that. Anybody any doubts in that? ठीक है, that is completely average. Till now everything was average. है ना? So another line you can write is that if line AB is a chord, slope represents average speed. ठीक है, this is another line you can add just for clearing, having a clear idea. ठीक है, now let's move on to instantaneous. What do you mean by instantaneous? It can give both average speed and average velocity both. ठीक है, if you are taking it as displacement, if you are writing displacement, then it will be velocity. If you are taking it as distance, then it is speed. ठीक है, slope can give both. है ना? अच्छा, ठीक है, हाँ. So this was, everything was average till now. Now let's move on to instantaneous. What do you mean by instantaneous? Anybody who can just give a vague idea of what is instantaneous?
Sir, at a particular instant, what is happening?
At a particular instant, that means the time interval. ठीक है, when I said at an instantaneous means at an instant. गजब. ठीक है, good one, but ठीक है ना? ठीक है, don't get offended है ना? I do such things. Don't worry about it. अच्छा, now see, when you said, sir, this is from T1 till T2. ठीक है, this is a big, a large time interval. 5 seconds is a very long time. Yeah, 5 seconds is a very long time. In fact, 1 second is also a very long time. That is also a time interval. ठीक है, what you need is a instant. ठीक है, instant. Suppose I am saying at t equal to t2 seconds. That means at this point only. ठीक है, so imagine what I am doing here. Just try to imagine what is happening here. This was A, this was B. ठीक है, this was A, this was B. This is having some delta t. This is some time difference. ठीक है, there is a big time interval between A point and B point. ठीक है, now what I do, I want to find velocity at t equal to t2 seconds. ठीक है, if someone says find velocity at t equal to t2 seconds, that means they want instantaneous velocity. ठीक है, they want an instantaneous value. ठीक है, why I am saying instantaneous? Because it is only just for 1 instant. ठीक है, not even 1 second. It is very small. ठीक है, it is so small that you cannot measure it. है ना? That instant is very small. ठीक है, so if we want to find instantaneous velocity, instead of it being over a time interval, if I want it at only t2, ठीक है, what I start to do is I start to move this line towards t2. Okay, I start to move this line towards T2. Earlier, the slope was being represented by this line. Okay, yeah, it was being represented by this line. Okay, this chord AB, slope of chord AB. Now, since this line, this T1 line has moved towards right, you can say that it is now at this point. Okay, it is now at this point. Okay, this line has moved till over here. Okay, so this line is over here. That means A point has shifted over here. Now this is my A point. Okay. Now again, if I draw the graph, if I draw the chord, sorry, like this. Okay, this chord is still representing average velocity between A and B. Why? Because it is still having some time interval delta t. Okay, so what I do, I shift it more. Okay, नहीं, dividing of strips is an integration. Okay, don't confuse it. I am not dividing it into strips. I am moving this line towards the right. Okay, now what I do, I again shift it very close. Okay, so close that it is just behind a B. Okay, it is very close like this. Okay, it is very close. It is very close over here. It is A. Okay, so A point has shifted over this point now. Okay, I have shifted that line towards right. So that is a very close to B. It is like it is just over the point B. Hai. So when you join these 2 points, A and B point, you will be having drawn you would have drawn here a tangent. Yeah, it will come to rest. Okay. It is moving now. How will it come to rest? Okay, it has not come to rest. It is still moving. It is still moving. Okay. But I am talking about graph. This is graphical method. Okay. Actual motion is happening somewhere else. Okay. This is on the graph. This is what I am doing on the graph. Okay. So practically what I have done. Okay. Practically everything is going on. Theoretically what I have done is that I have taken this T1 line and pulled it very close. Okay. Very close to B point. Okay. Very close to T2. Now this interval, okay, this interval is so small, okay, it is so small that you cannot measure the difference between the two. Okay, practically there is no way to measure the difference between the two lines. Okay, I have drawn it with a bit difference, but if you draw it so close that you are unable to measure the difference, then it starts representing instantaneous velocity. Okay, this green line which is tangent to the graph is now showing instantaneous velocity at point B. Okay, the slope of this line, okay, this is representing the instantaneous velocity or speed, whichever you want, at t equal to t2 second. Okay, because slope was representing earlier also, it was representing speed or velocity only. The only difference which we get here is it has started representing the instantaneous speed. Is it clear? Okay, that means what final conclusion you can draw from this is that suppose I have a xt graph like this, and someone has asked me to find the instantaneous velocity at time t2 seconds. So what I do, I just draw a tangent at this point. I just draw a tangent at this point and calculate its slope with the x-axis. Okay, this is the x-axis. The angle made by it is theta. The slope is tan theta. ठीक है, you can extend this line behind also, ठीक है, it will somewhere be cutting the x-axis. So here also this angle is still theta. Both the angles are same. Okay, they are you can say corresponding angles. So this slope now will start to represent instantaneous velocity or speed, whatever. Okay, did everybody get this? This is tangent. Remember, this is tangent. Tangent is a line which touch the curve at one point. Okay, and chord is a point which touches the curve, which cuts the curve at 2 points. Okay, so if it is a chord, the slope of the chord gives me average. If it is a tangent, the slope of tangent gives me instantaneous. Is it clear to everybody?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So just write the statement here that a tangent, ठीक है, if the line ऐसे नहीं ऐसे लिखो, if line is a tangent, then slope represents instantaneous speed or velocity, whatever. Okay, this is the final, you can say, the graphical meaning of differentiation. Okay, the method to calculate the slope. Okay, I have just told you what is the definition of slope. Okay, I have not given you the method to calculate slope. Okay, till now. So the method to calculate the slope is differentiation. Okay, the way to calculate, the process to calculate the slope is differentiation. Okay, so you can write this way or method to calculate slope. This is differentiation. And so we will see this method in the next class. Okay, so those who want to write, you can write it. Okay, so that's it. In the next class, we will do this methods of calculation of slope, that is differentiation. Okay, the rules and all. Okay, we will do in the next class. So that's it. Thank you. So those who want to leave this over here, okay, those who don't want FBD can leave, others can stay.
So what's that?
Which one?
So the thing what you said.
About? ऐसे कैसे बता दूं? Last statement which I said just now.
So I sent so yes, so the FBD thing.
Means see, I am just going to discuss basics of FBD. Okay, free body diagram. I guess that is going on in your classes, in a regular class. So some of you had doubts about it. So I am just going to discuss in brief what it. Okay, it is not a very serious. Yeah, I sent
no problem.
Yes, just a minute. ठीक है.
How long will you take FBD?
What?
How long will you take to achieve FBD, sir?
I am unable to get any voice. It's very disturbed.
He's saying how long is going to be the
So you
FBD
saw
thing.
See, FBD is not a very big thing. Okay, I don't know why you are having doubt. It is just a method. So 10-15 minutes, not more than that. It should not take more than that.
So I
Okay.
sent the question to chat.
Just a minute. I'm seeing that. So where did you have the problem over here?
So that for finding the acceleration, that part, and also how to find how we got the second 53-degree angle. That I just wanted to know.
अच्छा ठीक है. So see here. ठीक है. So this is a mass m. ठीक है. 5 kg doesn't matter, let it be. This is 53 degree. ठीक है. Once you get the angle, you
Sir,
will get
can you
the
scroll up?
actually you are writing. ठीक है. Right. ठीक है. Just wait, I will explain this question. No?
Done, sir. Thank you, sir.
Okay, thank you. ठीक है. Don't I cannot say anything on that. ठीक है. But we will see what happens once your regular classes open. ठीक है. I cannot tell who sir will teaching and which classes sir will be teaching and which classes I will be teaching. So I cannot say on that. ठीक है. But we will see that. Don't worry about it now. अच्छा. So first of all, you need to find that how this angle 53 came. ठीक है. अच्छा. So this is 53 was given to us. ठीक है. Now you know that its mg is acting vertically downward. Okay, it is vertically downward direction. What we do is we take these two directions as our axis. Okay, this is x-axis and this is y-axis. Okay, I told you x and y axis are created by us, so we can make them however we like. Okay, we can draw those lines however we like. So this is represented as x-axis and the other perpendicular line is y-axis. Okay. Acha, now
So I have a
see.
question.
Yes.
So we can take mg is also y-axis, right?
You could have taken mg as y-axis, but you won't be able to solve it further. Okay, there
Okay,
would be
sir.
you won't be able to solve that further. So better to take whenever inclined plane is there, take one the x-axis along the inclined plane and y-axis perpendicular to it. So that is better, easier to understand. ठीक है. अच्छा, now this is 53 degree. ठीक है. This is 90 degree. ठीक है. So this angle will come out to be 37 degree. You can see that. ठीक है. It is 90 minus 53. That is 37 degree. अच्छा. Now see this and these two. ठीक है. These two are perpendicular to each other. ठीक है. These two lines are perpendicular to each other. Out of that, this is 37 degree. ठीक है. If you draw it correctly, let me just draw it a bit more correctly. ठीक है. mg was like this and this angle came out to be 37 degrees. Okay, so if this is 37 degree and this is 90, this complete is also 90, so this remaining part will be how much? It will be 53 degrees. Okay, so if it is 53 degrees, now you can take the components. Okay, you can resolve the mg vector as mg cos 53 and mg sine 53. Okay, so if mg sine 53 is in the downward direction, okay, if you see your block, there is no other force acting on it in the x direction. Okay, so since there is no other force acting on the x direction, the net force in the x direction is how much? It is mg sine 53 degree. Okay, it is mg sine 53 degree. So in x direction, in x direction you can replace F as MA. So it will be MAX is equals to mg sine 53 degree. Gets cancelled. So AX comes out to be g sine 53 degree. So this is how you get acceleration in x direction as g sine 53 degree. ठीक है? अच्छा, friction is also there.
According to how, so yeah, that in the according to how he did it, I didn't understand what he
अच्छा,
did
अच्छा.
in the that
Yeah,
step.
I did. That friction was also there. Sorry. ठीक है? If no friction is there, then this is the case. ठीक है? If friction would be there, so just see. Friction is there. ठीक है? It is moving है ना? अच्छा. 20 meters per second. अच्छा, now see, those who want to study free body diagram can also see here. ठीक है? What is free body diagram? Basically, I will tell you in this only. Now see, I had an inclined surface. I had a block. ठीक है? I had an inclined surface and I had a block. What I did was I started studying this block separately. ठीक है? When I remove something from the system, ठीक है? When I remove something for studying, for the purpose of studying it, it does not change its property. ठीक है? When I remove it over here and draw it over here, it does not mean that its velocity will become zero, its acceleration will become zero. It will still have the same velocities. 20 meters per second will still be there. It will be having some acceleration in the backward direction in the x-axis. ठीक है? This is x and this is y. This is x, this is y. So still it will have some acceleration in the x-axis. It will have some forces in the x and y-axis. What I do, ठीक है, free body diagram, is I just remove these other things. ठीक है, I remove this inclined surface so that I can clearly see what is happening with the block. ठीक है, so this diagram, this diagram which I have drawn over here is basically representing free body diagram. ठीक है, now I am going to draw the forces on it. ठीक है, then it will be a complete free body diagram. ठीक है, so if you see the forces, you will have a mg in the downward direction. You will have a mg in the downward direction. There will be a normal reaction acting like this, and there will be a frictional force, kinetic friction force, since friction is there given. Mu is equals to 0.5 is given. So since there is a frictional force acting, okay, since there is friction, so friction force is also drawn. There are no other forces acting on the block. Hence, this diagram is now my complete free body diagram of the block. Okay, so this is called as free body diagram. That's it. Okay, free body diagram is something which you use to simplify the problem. Okay, you can easily see the forces in this case. So, okay.
So what is AX in the case?
Acceleration in x direction. Okay, my x-axis is this,
okay.
na?
Okay, sir.
So
Thank you, sir.
Okay, now see.
So also, so if the forces and all are in the acceleration direction, then it will be positive, like. And if in the
let me come to that. First, you learn to draw how to draw FBD. Okay, that is FBD. This is FBD. Okay, first you need to understand what is FBD. You all are confused for FBD. I don't know why, but it is just a method to represent. That's it. Okay,
So,
yes.
so what is that BK?
Where?
The down that side besides MG.
What
so that's FK.
friction, sir?
This is FK.
FK is
FK.
Friction, kinetic friction force.
Pseudo force. Okay.
It is kinetic friction. ठीक है, pseudo I will explain
Okay,
that.
sir. Sorry.
ठीक है. अच्छा, now let's get back to this, है ना? now you have just seen that I had taken two components of mg. Okay, one was mg cos 53, one was mg sin 53. Still the components will remain the same. Okay, mg can be written in two forms, that is mg cos 53 and mg sin 53. Okay, once you have resolved mg, okay, once you have resolved mg, you can remove the force mg from the system like this. Okay, so I have now this is my new free body diagram. Okay, this is my new free body diagram. Acha, now let's solve this question in two directions. Okay, that is in x direction and in y direction. Okay, if we are talking about x direction, okay, you can write fx is equals to max. Okay, net force in x direction can be written as mass into acceleration. That's it. Now, what about fx? If you are talking about fx, fx is the net force in the x direction. So you can see that fk and mg sin 53 are in the same direction. Okay, but we don't know whether it is positive direction or negative direction. Okay, for that we go to acceleration. Okay, we see ax is in this direction, so we say that this direction will be positive, not this direction. Okay, you can write x in that direction,
So
but the direction,
how you get to know the direction of acceleration?
you can assume it doesn't matter. I assume that acceleration is in the backward direction. You can assume it in the
So
forward
that
direction.
20 meters per second is not the reason, right? It's
No. You don't have to worry about speed. There is no connection between speed and acceleration. There is only that equations of motions are there. That's it. Okay, there is no connection between the
so
direction of velocity and acceleration.
So we can assume acceleration to be in any direction.
Yes, you can assume it in any direction. Okay.
so in the
Suppose
sum, why did you so put minus in the outside the bracket in the working?
Just let me see.
Excuse me, sir.
Acha, sir must have taken one particular direction as positive. Okay, so he must have drawn there is direction for
So
acceleration
you
which
took the other direction.
I took the other direction which sir has taken. That is why. Okay, let's go with sir. No problem if you are having confusion. Let's go with sir only. Okay, let's say that this direction is the acceleration direction. So this direction will become positive. Okay, no problem that you can assume whichever direction you want. Answer will be the same. Okay, now see, acceleration I have taken as upward, so upward direction is positive for me. Now you can see that fk and mg sin theta are both in the downward direction. So what I will write is fx as minus mg sin 53 minus fk. Okay, both are in the negative direction, so both are having negative sign with them. Okay, this should be equal to max. That's it. Okay, now if you calculate this max, okay, you will have minus g sin 53 minus fk by m. This is the value. So from here you can safely say that minus sign can be taken as common. It will be g sin 53 plus fk by m. Now you can see that this complete term is positive. Whatever happens, this is positive, and it is being multiplied with a negative sign. That means you have acceleration something as negative. Negative acceleration means that the direction which I had assumed for acceleration was wrong. Okay, my acceleration should have been in the opposite direction. That's it. Okay, physics cleared your doubt. Okay, you assumed something else. Physics gave you some answer. It said that no, the assumption was wrong. It is in the opposite direction. That's it. Okay.
Yes, sir. Got it, sir.
So
ठीक है, so
that last part, can you explain again?
हाँ,
So that
when
AX and all from
हाँ,
the AX.
see, I had assumed my acceleration in x direction was in the upward direction like this. Okay, we assumed that only, that it is in the upward direction. So that is why we considered that side as positive. Okay. Now when we calculated everything, okay, when we calculated, we divided it by m. Okay, we got ax as this. Then I took minus sign common. Okay, then I got ax as this. Now if you replace the values over here, g sine 53, fk and m, okay, g sine 53 will be positive, 10 into sine 53 will be positive, and fk you know, fk is written as mu into n. Okay, mu is given to you, n will be mg cos 53. Okay, you know this. Okay, n will be mg cos 53. So when I replace here, I will have fk. Okay, so fk is also coming out to be something positive. You can see that. So if this is positive, this is positive, this is positive, this is positive, so everything in this bracket is completely positive. And I have a minus sign outside it. Okay, just a minute, I will explain that. I have a negative sign outside. So that means whatever be this value, I will have something negative as the answer. Okay, suppose 11 is coming out to be the answer, 11 meters per second square. So I will have the answer as minus 11 meters per second square. Okay, minus 11 means what? That physics want to say that the direction which you have assumed was not the correct one. Okay, my correct answer should have been, my correct direction should have been in the backward direction with a magnitude of 11 meters per second square. That's it. Okay,
Sir,
if you
is that
would,
due to retardation?
you can say, okay, that physics gives you, okay, physics tells you the answer that it is a retardation. Okay.
Okay, sir.
So basically it is giving you the direction as negative. Now suppose I would have solved with this direction only. Suppose I would have solved with the downward direction as positive only. My answer would have come as plus 11 meters per second square. There won't have been any negative sign involved. Okay, so it doesn't matter what direction you take. Whichever direction you take, your answer will be same. Okay.
So which is the correct answer? Minus 11 or plus 11?
See, again, both are correct depending on your sign convention. If you are taking this as positive, minus 11 is the answer. If you are taking this as positive, plus 11 is the answer. Okay, so depending on your sign convention, your answer will be correct. Okay, is it clear? Yes,
Yes,
you
sir.
can achieve
Yes.
any direction. Okay, the relative direction you are getting, that its acceleration is towards the ground. Finally, you can say that the acceleration of the block is towards the ground. That's it. It is not away from the ground. Okay, that is a more, you can say, understandable direction. Okay, instead of saying plus
So
and
you can
minus.
solve that bracket.
Which bracket?
So AX. So
Acha,
whatever
this
was
one.
given in AX. So
So
just show the working.
okay, just let me move this one right again. Okay, so I had g sine 53 plus fk by m. Acha, so fk is mu into n. Mu is how much? Mu is 0.5. 0.5 into mg cos 53. Okay, mu is 0.5 and n is mg cos 53. So fk comes out to be 0.5 mg cos 53 is 3 by 5. 3 by 5. Okay, so this is the value of fk. You can replace fk over here. If you replace fk over here, you will have minus of g sine 53. Sine 53 is 4 by 5. Sorry, it is 4 by 5 plus fk is 0.5 mg 3 by 5 upon m. Mm gets cancelled. So I have minus G 4 by 5 plus this is 0.1 into G3. So G can be taken as common, minus G outside, 4 plus take the LCM. So this is 15, 1.5 by 5. Yeah, so this is the value. So minus G into 5.5 by 5. So this is minus G into 1.1. So G is 10. So this is, comes out to be minus 11 meters per second square. Okay.
Yes, sir.
Okay, so
Hmm.
so in the bracket it was G sine 53 plus Fk upon M, no?
Yes, yes, yes.
Okay, so
Okay. And so I guess everybody is getting what is FBD. And FBD is just this diagram. That's it. If you can draw this, you know how to draw FBD.
Okay, sir. Thank you so much, sir.
so and and along the X direction for Fnet we are not using 20 meters per second.
That is speed. I have no use
So
of speed. F is
so
equals
that
to
is
mx.
not used at all.
No need for that. Okay, this thing just gives an idea. 20 meters per second square is just giving you the hint that instead of static friction, you have to use kinetic friction because it is moving. Okay, there could have been a possibility that it was at rest over here because of the friction. Okay, so if it would have been at rest, the static friction would have acted in the opposite direction, and mg sine 53 would have been like this. Okay, so since it is moving, the friction is kinetic and opposite to velocity. Okay, that is why my kinetic friction was like this. If this 20 meters per second would have been in the opposite direction, my Fk would have been in the opposite direction. Okay, so that is just giving you the direction of frictional force, kinetic friction. That's it. No use of the magnitude.
Excuse me, sir.
Yes.
So when we have problems where there is tension and there is gravitation also, how do we know which force is greater?
Acha, okay. See, again, we cannot find which force is greater. Okay, like just let's take a standard pulley system. Okay, block pulley system like this.
Sir,
So
we
you
can
took G as
assume
10.
no.
क्या? One at a time.
So G you took as 10.
G is 10. G is 10. G is always taken as 10 until mentioned otherwise. Okay, if they say to use it as 9.8, then only use. Otherwise, it is 10 only. Okay. Acha, now see. Suppose I have been given this as 5 kg, 10 kg. Okay. And I have to find what is the acceleration of this 5 kg block. Okay. So first of all, what you draw all the forces in it. Okay. You draw the forces, you draw the tension, you write mg 5g, you write 10g 5g over here, mg. Okay. Now I don't know what is the acceleration. Okay. Anyways, you know that acceleration is in the downward for 10 kg and for 5 kg it is upward, but still I don't know. Okay, just assume that you don't know. Okay, if you don't know the direction, assume any direction. Okay, let's say that it is having acceleration in the upward direction. Let's assume, no problem in that. Okay, if the acceleration of 10 kg is in the upward, the acceleration of 5 will be in the downward. Okay, it doesn't matter because if this goes up, 5 will come down. Okay, so acceleration of 10 is upward, 5 will be downward with the same magnitude. Doesn't matter. Okay, now draw the FBD of 5 kg. Okay, 5 kg FBD is what? Draw all the forces. All the forces are what? T and 5g. That's it. There is no other force of the on the 5 kg block. This is the FBD of 5 kg block. Okay. Acceleration is in the downward direction. So what I can say that this direction will be considered as positive for 5 kg. Okay. So I can write F is equals to MA. mg, 5g is in the positive direction, so plus 5g. T is in the negative direction, so minus t. This is equals to m. M is 5. 5a. Okay. This is the first equation you can say. Okay. Next, we go on to the 10 kg block. We go on to the 10 kg block. Again, I draw the FBD of 10 kg block. The FBD of 10 kg block is what? This is tension upward, 10g in the downward direction, and its acceleration A is in the upward direction. Since its acceleration is in the upward direction, the upward direction will be considered as positive for 10 kg. Okay, so again, if I write F is equals to MA, I can write what? Upward plus T, mg downward minus 10g. This is equals to m 10a. This is the second equation. If you add these two, 1 plus 2, you will have 5g minus 10g is equals to 15a. Okay, so if you solve this, you will have minus 5g is equals to 15a. A is equals to minus g by 3. C. I assumed that the acceleration of 10 kg block was in the upward direction, but on calculation, physics is telling me that acceleration is minus g by 3. That means the direction is opposite. The acceleration of this is g by 3 like this, and the acceleration of 5 kg is g by 3 upwards. Okay. So doesn't matter whatever direction you assume. Okay, just assume a direction. Okay, it won't have any effect whether you are assuming the correct direction or the wrong direction. Okay, physics will just give you the correct answer. Okay, so you don't have to worry about all those things. I assumed in the opposite direction. Na? A and A, both the blocks will have the same acceleration. What did I do here? I assumed the wrong direction only, na? And still I got g by 3. Okay, minus g by 3. That means the physics what it wants to say to me is that it is in the opposite direction. The magnitude is g by 3 only, but in the opposite direction. So what I did is I reversed it. I changed the direction and wrote like this. Okay, is it clear?
Okay, sir.
So it won't matter whatever direction you take, answer will be same. Just have to assume some direction and move forward. Okay. A few doubts are there. Lakshmi, the momentum and time. ठीक है. ठीक है. Now 15th question, if we see the momentum P of object varies at shown in the figure, the corresponding force at T equal to 1 second is. Okay, they want the time force at T equal to 1 second. So first of all, if you want force, okay, you have to go to basic definition of force. Force is defined as dP by dP by dt. Whenever I write dP by dt, this means it represents the slope of PT graph. It is representing the slope of PT graph, which I was going to discuss in differentiation. Okay, so I have not yet discussed, but dP by dt means slope of PT graph. So what the question is asking is स्लोप ऑफ पीटी ग्राफ, ठीक है, at t equal to 1 second. Slope of PT graph at t equal to 1 second. हाँ, this is differentiation. ठीक है, this is the use of differentiation. ठीक है, so at 1 second, if you see this straight line is there, ठीक है, the tangent to this straight line is this straight line only. ठीक है, the tangent to a straight line is is the straight line itself. ठीक है, so at this point, if you write the slope, okay, if this is theta, so tan theta, if you see this triangle, okay, tan theta can be written as 10 by 2, that is 5. So the force at t equal to 1 second is 5 Newton. Khatam. Okay, so similarly, I guess all the questions are asking this only.
Excuse me, sir.
Hmm.
Sir, very sorry, sir. I had got disconnected, sir. So
Acha.
network issue was there. So could you please explain this again, sir?
Yes. Okay. So what we have here is a PT graph, and they want force at t equal to 1 second. Okay. So force can be written as dp by dt. dp by dt means what? It is the differentiation of p with respect to time, or in terms of graph, it is slope of PT graph. Okay, it is slope of PT graph. Acha. So basically what the question wants us to find is what is the slope of the graph at t equal to 1 second. Okay, so at t equal to 1 second means instantaneous. They are asking instantaneous means I've just told you that instantaneous, if anything is instantaneous, it means it is tangent. Okay, they want the slope of the tangent. So first of all, I need to draw the tangent. So tangent at a point on a straight line is the line itself. Okay, if you are drawing a tangent to a curve, then it will be some different line. But if it is already a straight line, if you draw a tangent over here, it will be the same straight line. Okay, so what I did is I just calculated the slope of this straight line. Okay, so how to calculate? This angle is theta. Slope is defined as tan theta. So if you see this right angle triangle, okay, this height is 10, this length is 2. So tan theta, if you write, it will be 10 by 2, that is 5, and that will be the slope at point 1. So that will be the force at t equal to 1 second.
Yes, sir.
Okay.
Got it.
Yeah.
Thank you, sir.
Okay. Any more doubts, anybody?
So can you please explain pseudo force in brief, please?
Pseudo force, acha. Now see, suppose let's see that I have a block like this, and a block is over here. Okay, and a person is also standing over here, and a person is standing on the ground like this. Okay. Now, just imagine that this block is moving with some acceleration. Okay, suppose this block is moving with some acceleration. Okay, it is like that you are sitting in a bus, and the bus suddenly starts. Okay, if the bus suddenly starts, you experience a force in the backward direction. You know that. Okay, so it is something like this only. When this bigger block is having acceleration a, this man will experience a force in the backward direction. Okay, but this man on the ground won't feel any force. Okay, the man on the ground cannot feel anything. Okay, he will be standing there only. He will say that you are having acceleration a. Okay, let's name this as 1 and 2. So observer 2 will say that I am experiencing a force in the backward direction, but observer 1 will say I am experiencing no force. Okay, so what is the force? Okay, that's something which is creating a difference between observer 1 and 2. is your pseudo force. Pseudo. An observer starts to accelerate, he experiences a force in the opposite direction of acceleration. That force is basically your pseudo force. Okay. So there is a method to write pseudo force. First of all, the magnitude. Okay. The magnitude of pseudo force is the mass of object into acceleration of observer. Okay. Mass of object into the acceleration of observer. If the bigger block is accelerating with A, this second observer will also be accelerating with A. Simple as that. Okay. So the acceleration of the observer is A. Now suppose I am asking this second observer to write the forces on smaller mass. Okay. What he will say that he will add a new force, that is pseudo force, with a direction. Okay. Magnitude is this, direction is opposite to acceleration of observer. Okay, the direction of the pseudo force is opposite to the direction of acceleration of observer. So observer is accelerating in the front direction. Okay, but the pseudo force is acting in the opposite direction. And what is the magnitude? Magnitude is mass of the object. Object's mass is m, and acceleration of the observer is what? It is a. So a pseudo force of m into a acts in the backward direction. That is pseudo force. Okay, it is an experience, you can say. Okay.
Yes, sir. Thank you, sir.
Okay, thank you. Okay, so
Thank you, sir.
okay, so that's it for today, है ना? What time हो गया? 3 घंटे हो गए almost. So any more doubts? We will discuss it in the next class, है ना? Next Sunday we will discuss again all these. Okay.
Thank you,
Okay, sir.
sir.
Thank you.
Thank you very much, sir.
Thank you.
Thank you, sir.
Thank you.